Welcome to the presentation of our paper, Gesture Recognition with Keypoint and Radar Stream Fusion for Automated Vehicles. First, I want to motivate our paper. The gesture recognition in the field of autonomous driving is necessary for safe interaction between persons and autonomous vehicle. Furthermore, we can increase the robustness of gesture recognition against single sensor issues. The contribution of our paper is a two-stream neural network architecture for the fusion of keypoint and radar data for gesture recognition using a STMLP for the temporal processing and the auxiliary loss during the training. We are the first which uses radar and keypoint data for gesture recognition in autonomous driving. Our proposed network architecture is a two-stream architecture with a separate stream for each modality. In the whole model, we replace the recurrent layers with STMLPs, and additionally in the radar stream, we use the point net for the radar data processing. The training of the model is done with the cross-entropy loss, which uses the ground truth gestures as labels. Additionally to the fuse prediction loss, we use some auxiliary losses for each modality, here shown in yellow. The task of the auxiliary losses is also to predict the shown gesture, and therefore we use the cross-entropy loss. The overall loss is a combined loss of the auxiliary losses and the fused loss. The dataset we use for the training of our architecture contains data of one camera and 3 radar sensors, which are synchronized by a trigger with 15 frames per second. In the dataset, 8 different gestures are included, performed by 35 persons. During the evaluation, we use the cross-subject evaluation and include 28 persons in the training and 7 in the testing set. For the final evaluation, we calculate the mean over 5 different training test splits. In the evaluation of our architecture, we compare a STMLP version with the LSTM version. And in the first part of the table here, the single modality, we only use one modality for the training and testing. And the SM training, the skip modality training, means that during the training in 30% of the samples, one modality is skipped. And as we can see here in the table, the fusion results are around 4 percentage points better than the single modality. And also the STMLP architecture achieves better fusion performance than the LSTM architecture. During the evaluation in the last slide, we use both modalities for testing, and here now we only use one modality during testing but train with both modalities. And this is comparable with one fully corrupted sensors, for example, due to adverse weather or technical problems. And as we can see, testing with only one sensor causes a performance drop, but with our skip modality training, we can prepare the model for missing modalities, and therefore the performance can be improved. Thank you for your attention.